and welcome back to the lecture series of learning theory of automata and formal languages. My name is Binayak Parashar. I am working as an assistant professor in the Department of Computer Science and Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, this is your unit number 1 that we are continuing, and this is lecture number 8, where we will be finishing up with the concept of finite automata with output, the equivalence property of Mealy and Mealy machine. So, let us check it out what is the agenda of today's session. Today's session we will be looking into the equivalence part of what Mealy and Mealy machine is all about. Okay. So, till now we have seen the basic designing process of finite automata. It starts with finite automata without output, that means deterministic finite automata, non-deterministic finite automata, and NFA with epsilon transition, that means non-deterministic finite automata with epsilon transition. So, till now we have seen all the designing process of all each individual machines. Along with, in the previous video we have understood the concept of how to design a Mealy machine as well as a Mealy machine. Now, we will try to check it out the equivalence property of Mealy and Mealy machine. That means, some or the other these two machines are the one which will accept the same language, and definitely there is a way of converting one machine to another machine and vice versa. So, let us check it out some of the significant properties of this, and then we will try to look into how to convert Mealy to Mealy and Mealy to Mealy. Okay. So, let us check it out the first slide. So, as we go back to the first slide, I am just getting back a little bit of revision of what we have understood in the previous session till now. So, we have come across with the concept of finite automata in first or 2 video lectures. If anyone has skipped till now, then you can just get back to the lectures. So, then we have come back across with finite automata with output, which is one category. Another category is finite automata without output. So, if you look into finite automata without output, we have started off with DFA concept, that is deterministic finite automata. Then we have come across with NFA, or sometimes it is mentioned as NDFA. So, do not get confused, not non-deterministic finite automata or NFA. Then we have come across with the last topic, that is your NFA with epsilon transition. So, this is what normally says without output. Without output means we are having states which will declare whether the string is accepted or rejected. Here we will not have any kind of output alphabet with the help of which the string will be having some set of acceptance with the language. No, but in the case of finite automata with output, we will not have any kind of final accepting state, or we can say final rejecting state. Rather, we will be having an output alphabet which will designate this property of acceptance and rejections. Okay. So, that means with output we will be having 2 machine, one is Mealy machine and the other one is your Mealy machine. So, in the previous video or in the previous class, we have seen about the construction or designing process of Mealy machine as well as the designing process of Mealy machine. So, if we look into these 2 machines, a small difference I am just telling, I will take only 1 or 2 minutes, where we will discuss a little bit of understanding of what Mealy and Mealy is all about. In Mealy machine, the output alphabet is associated with the states. Okay. Whatever states are present, let it be initial state or let it be another state, okay, output alphabet will be associated with the states. Whereas, in the case of Mealy machine, suppose we are having some input transitions over here, suppose this is A, this is B, suppose this is C, and there is a self loop of D suppose. So, these are suppose input transitions. In the case of Mealy machine, the output alphabet will be associated with these transitions as well as the present state. Why present state? Because from that particular state only the input transitions will occur or input transitions will generate. That is why we have to consider the output alphabet along with the input transition as well as the present state. So, this is the general difference between Mealy and Mealy machine. But in the case of these machines without output, we are signified with what? With a accepting state, final state we can say, with the help of which we can say that the particular string is being accepted or rejected. Okay. Rejected means suppose we are not having a state from where there is no transition going back to the initial final state, then that state particularly we can say that the reject state. So, I hope you have understood till here a clear cut idea of what these machines are all about, and let us check it out today, the equivalence concept of this particular Mealy and Mealy machine. Okay. Whenever we say equivalence concept, some or the other we try to signify both the machines together into one category and try to find out the equivalency between both of these machines, okay, or similarities between both of these machines. So, if we look into all these machines, what is the basic similarity? The basic similarity is the language that is being asked. So, suppose if a machine is suppose I am having a machine say M1 and another machine say suppose M2 and both the machines accepts the same language, then can we say that M1 and M2 are equivalent to each other? Yes, exactly. So, that is why we have to find out certain equivalent property in this case, that whether the Murray and Mealy machines are equivalent to each other or not. Let us check the first point. In the case of Murray machine, I have mentioned already, the output is associated with every state, and in the case of Mealy machine, the output is associated with the input transitions as well as the present state. So, present state I have not mentioned, but input transition is the preliminary concept. Okay. So, this is what the difference between Murray and Mealy machine. Now, come the next point, the equivalence of the Murray machine and the Mealy machine says that both the machines generate same output for the same input. Okay. What the equivalence property says, that for both the machines it generates the same output for the same inputs. So, some or the other they are accepting the same language, correct. That is why they are generating the same output based on the same inputs, got it. So, then we can say the equivalence property exists. Okay. So, this is all about the equivalence property in the case of Murray and Mealy machine, which we have already studied in equivalence property of NFA and DFA, almost similar to each other. But two points are important to keep in mind, that is why I have put it as a note over here. First point says that in the case of Murray to Mealy conversion, number of states remains same. Please note, if you can note it down, it will be easy for you guys. And in the case of Mealy to Murray machine, okay, number of states will not same, it will increase, or it will not decrease also, it will increase. So, this is a very important point from your exam point of view, from your like competitive exam point of view, from MCQ point of view. I think probably this semester you are giving MCQ. So, MCQ point of view is also it is very important, clear. So, this is all about the equivalence property. Now, let us go to the next slide. Next slide says a little bit of a methodology that is being depicted in the book. So, it says that let M be the machine that comprises of 5 tuples, which are nothing but what? States, input alphabets, transition function. What is this one? What is this symbol is all about? I will let you know about this one. This is nothing but the output alphabet, and this is your initial state. Be a Murray machine. Okay. So, output alphabet sometimes it is mentioned like this, sometimes it is mentioned with this alphabet. Okay. And the equivalent Mealy machine can be represented by M dash. So, that means I am having a Murray machine, okay, which is represented by capital M, and a Mealy machine which is represented by M dash. Okay. Both are having the same attributes. Now, come to the main point, the output function, that is tell this, can be obtained as this one, where it should be equivalent to what Murray machine transition output function is all about. So, if the output function of Murray machine is equal to the output function of Mealy machine, then we can say that both the machines are equivalent to each other. So, some way or the other we need to find out this particular concept only in order to prove that both the machines are equivalent to each other. So, we will not going to prove, we are going to find out the methodology how to convert the Murray to Mealy and Mealy to Murray. Let us check this particular concept in the next particular question. So, here I have mentioned some of the steps, but later on I will show it to you. Later on I will be discussing a properly this particular example. Okay. Let us check it out what are the steps involved. So, generally the first concept that we are going to learn is converting a Murray machine to a Mealy machine. Okay. Converting a Murray machine to a Mealy machine. So, for that first step is that if the transition diagram is given, suppose you never know, in question paper they might give you as a transition diagram, or you might get a transition table. So, depending on that. So, if the transition table is given to you, then this step 1 no need to do. Step 1 indicates that if the transition diagram is given to you, then convert the transition diagram to the transition table as shown in this particular step, correct. Transition diagram is given, this is a Murray machine. How can I justify that this is a Murray machine? Because the outputs are associated with states, outputs are associated with states, correct. and this table will be what? States will be there, input alphabets will be there, and the output, these output alphabets are the one which are corresponding to the states. So, if I draw the particular transition table, the attributes will be like this: q naught and q 1. Okay. So, A and B are the two inputs, okay, and for q naught output is what? 0. So, write down here. For q 1 output is what? 1, write down here. Clear? Next comes what? Q naught on seeing A, where it is coming? It is coming to itself. So, you can write it down as q naught. Q naught on seeing B, where it is going? It is going to q 1. Q 1 on seeing A, where it is going? Q naught, and q 1 on seeing B, where it is coming back? Q 1. So, this is the transition table. This is how you need to operate the first step. Clear? Next goes with the second step. Second step says that in the second step, convert the transition table of the Murray machine to transition diagram of Mealy machine, where the output will be associated with the transitions. Got it? So, now we need to convert the transition table that we have got for the given Murray machine to the transition diagram of the Mealy machine, and then finally, you can write down the transition table for the Mealy machine if you want, but this is the step 2, and how to do that I will show you with an example. Okay. Next comes some of the steps for converting a Mealy machine to Murray machine. Till now we have seen 2 steps which is involved in the conversion of Murray to Mealy. Now, we will be checking the converting a Mealy machine to Murray machine. Clear? Step 1 says that if a transition diagram is given, then convert the transition diagram into transition table. Step 1 is exactly similar to what we have got in Murray to Mealy conversion. Clear? Now, comes to step number 2. From the transition table of Mealy machine, find out such kind of states which are showing more than one outputs. Now, this is the, like you can say, the most like critical one, which you need to understand very nicely with an example. Right now, I am pretty much sure you will not be able to understand step number 2, because once we deal with the example, then this particular point will be easy to you. Okay. Otherwise, it will not be, you will not be able to relate. For the time being, you just keep in mind that we need to find out certain states which are having more number of outputs in the transition table. Okay. So, let us check it out with an example. Come to step number 3, then in such cases divide those states into more states depending on the outputs associated with them. So, suppose I am having I find out from the table that this particular state is having more number of output alphabets, then I have to divide that state into different output alphabet states. Okay. That means, if you look into this particular point, then in the case of conversion of Mealy to Murray machine, will the states be same? No. There might be a chance of increasing the states, but not decreasing the states. That's why in the first slide I have shown it to you that in the case of Murray to Mealy conversion, number of states will remain as it is, but in the case of Mealy to Murray conversion, number of states will increase. Clear? So, let us go. I think overall I have tried to make you understand all the steps involved in both the conversion process. I have tried to explain to you what is the concept of the equivalence property, and now we will check 2 examples. One example will we will consider for conversion of Murray to Mealy, and the next example we will try to convert Mealy to Murray. Okay. Now, the same question that I have taken in the stepwise description. So, I think this is particularly clear to you all. So, I will just take the steps fast. Q naught Q 1, Q naught is having an output 0 and it is having an output 1. So, Q naught on seeing A, it is coming back to Q naught on seeing B, it is going to Q 1, Q 1 on seeing A, it is going to Q naught, and Q 1 on seeing B, it is going to itself. So, this is the particular transition table for the given diagram. Okay. Now, what we need to do? We need to find out the transition table, transition diagram for the Mealy machine. Okay. Now, before that before going into transition diagram, first of all, let us like convert this particular concept into the transition diagram. How to do this? Now, the most important easy way of working with this is that let me take the particular states. How many states I am having? I am having Q naught and having Q naught. Okay. Now, the most easiest way of understanding is that the outputs will not be associated with the states, rather it will be associated with the input transitions. Clear? Now, let me check the output of Q naught. What is the output of Q naught? Output of Q naught is 0. Output of Q naught is 0. Now, let me check for input transition A. When Q naught seeing on input transition A, it comes back to where? Q naught only, that means it will be a self loop A. Now, what is the output associated with this Q naught? 0. So, that means A slash 0. So, this is the way you need to write it, you need to fill it up. I think this particular concept I have shown in the previous video also. Okay. Next goes with input alphabet B. So, Q naught on sync B, where it is going? It is going to Q 1. Done. And what is the output of Q naught? What is the output of Q 1? Sorry, because Q naught on sync B is going to Q 1 and Q 1 output alphabet is what? 1. So, therefore, B slash 1. This is the way you need to fill it up. Got it? Now, come back to Q 1. Q 1 on sync input alphabet A. Again, I am repeating Q 1 on sync input alphabet A. Where it is going? It is going to Q naught. That means, Q 1 on sync input alphabet A. It is going back to where? Q naught. And what is the output alphabet of Q naught? 0. So, that means A slash 0. Clear? Last Q 1 on sync alphabet B, where it is going? It is going to itself. Okay. And Q 1 on sync alphabet B, input alphabet B, it is going to itself Q 1, and what is the output alphabet of Q 1? 1 only. So, B slash 1. Therefore, this is the final transition diagram of your Mealy machine. So, whatever diagram was there in the case of Mealy machine, almost what almost you will be getting the same type of diagram in the Mealy machine. Okay. Only the outputs will be moved from the states to the input transitions. How to find out? I have explained with the help of a transition diagram. Okay. Now, if we look into this particular concept, let me fill up the transition table first. I will be having states as Q naught and Q 1. Okay. Now, if you look at input 0, what is the state it is going for input 0? Sorry, this will not be input 0, this will be input A and this will be input B. Okay. So, on sync input A, where it is going? On sync input A, it is going to itself, correct. So, that means, what I can write it down? The state will be Q naught, and on sync input A for state Q 1, what it will be? It will be Q naught, correct. Done. Now, on sync Q naught on sync input alphabet B. Let me get back to the previous diagram. Q naught on sync input alphabet B, where it is going? It is going to Q 1. Therefore, I will be writing here as Q 1. Now, if you go back to the diagram, Q 1 on sync input alphabet B, it is coming back to itself. Now, this is what I have filled temporarily, what we have done in the transition table of Mealy machine, right. Now, let me get back to you now the main concept, that how to write down the outputs for this. See, if we have to write down the outputs for this Q naught, now if you get back to the diagram, Q naught on sync input alphabet A, it is coming back to Q naught, and what is the output of Q naught? 0, correct. You can check it out in the previous diagram. Q naught, what is the output? It is 0, correct. Then what is the output for Q 1? Everywhere it is 1 only, and Q naught 0. So, that means, whatever Q naught I am having, it will be 0, whatever Q 1 I am having, it will be 1. Therefore, this is the final transition table for the Mealy machine. So, I hope you have understood that first step is this one, okay, that you need to convert the transition diagram of the given Mealy machine to the transition table of the given Mealy machine. Okay. After that, what you need to do? You need to do conversion of the transition table of the Mealy machine to the transition diagram of the Mealy machine, and finally, if you wish, you can put this table as a transition diagram, transition table for the Mealy machine. So, this is how you can convert Mealy to Mealy. Okay. Now, let us check the next concept, conversion number 2. Here we are explaining that convert the following Mealy machine into its equivalent Mealy machine. Now, this is a vice versa process. Okay. Before starting with this particular concept, let me get back to the steps that we have mentioned over here. Okay, conversion of a Mealy machine to a Mealy machine. Here I have mentioned that if a transition diagram is given, then convert the transition diagram into transition table. So, in the question, in the given example, transition table is given to you. So, omit step 1. Let me get back to step number 2. It says that try to find out such kind of states which are showing more than one outputs. This is our focus, okay, which are having more number of outputs. Let me get back to the question. The question says that what are the states I am having? I am having Q naught, I am having Q 1, I am having Q 2, and I am having Q 3, correct. Q naught, Q 1, Q 2, Q 3. Now, look at the table. if we look into Q naught, okay, what are the outputs associated with it? See, outputs are 1 and Q naught output. Where is the output? Other table, go to the input number 1, Q naught output is 1. That means for Q naught, both the outputs are what? 1. Therefore, Q naught output is associated is 1. Clear? Let me get back to Q1. If we look into Q1, let me check it over here. Q1 1 output is 0 and Q1 1 output is 1. So, that means now we got a particular state which is having more than one outputs. That means Q1 is associated with two outputs, 0 as well as 1, 0 as well as 1. Okay, 0 as well as 1. Till here I hope it is clear. Now, one more thing we have to do, go back to the steps, and if we find out such kind of state which is having more number of outputs, in such cases divide those states into more number of states depending on the output associated with them, correct. No, as soon as we got a new state which is having more number of outputs, you have to divide that state. So, that means I will go along with the question. Now, Q1 will be divided into two categories. Okay, one is Q10. It is this nomenclature you can make on your own in order to remember that Q10 is associated with output 0 and Q11 is associated with output number 1. I hope it is clear to everyone. Now, let me get back to the next state, that is Q2. If we look into Q2, Q2 is having one output as 1 and Q2 is having one output as 0. Now, Q2 is another state which is having more number of output alphabets. So, Q2 also having more number of one output alphabets. So, that means Q2 also I need to divide. So, I will divide Q2 1 and I will divide Q2 1 and Q2 0. Okay, Q2 0 and Q2 1. This is the nomenclature that I am following. You can follow any of the nomenclature that you want. Okay. Now, be specific that whether which state is associated with which output alphabet. Clear? So, that means Q2 is done. Now, I can move into the Q3. So, if you look into Q3, okay, Q3 is having one output as 0 and Q3 is having one output as 0. Okay. So, Q3 does not have any problem. So, Q3 is having 0 only as the output. So, overall we got this particular scenario and we have justified step number 2 and step number 3. So, what is finally remaining? We just need to fill up the table right now. So, okay, how to fill up the table? So, just remember that Q naught is having output as 1, Q3 is having output as 0. How to do that? See. Now, let me write down the table first. Okay, the table will be like this: Q naught, okay, Q3, Q naught, Q2, Q1. Okay. Now, if we look into this particular table, let me erase this. First of all, let me erase this, and I will be directly involving the particular steps. Okay. So, if you look into Q naught, on seeing input alphabet 0, where it is going? Q3. And is there any change in Q3? Sorry. Is there any change in Q3? No change. Correct? No change. And in Q naught also no change. Only change occurs where? Q1 and Q2. So, that means in the next step, in the next table, Q naught on seeing A, it is going back to Q3 and output will be what? Output we will be writing later on, and this one will be having Q naught on seeing input alphabet 1. So, this is 0 and 1, sorry, this is 0 and this is 1. Okay. Now, Q naught on seeing input alphabet 0, it is going to Q3, output is 0, 1 Q1. Okay, 1 Q1. Now, 1 Q1. Okay. So, 1 Q1 I will write it down, but most importantly is that now output is what? 1. Which is the state of Q1 which is having output as 1? Q11, correct. Now, in the place of Q1 I will write what? Q11. I hope till here it is clear to everyone. Okay. Next step, what I will write it down is that I will write it down next alphabet, that is Q1. Okay. Next alphabet is Q1, next state is Q1, sorry. Now, if you look into the table, Q1 on seeing input alphabet 0, where it is going? It is going to Q naught. So, is there any change in Q naught? No, Q naught is fixed, whose output is what? 1. Therefore, I will write as q naught comma, okay, q naught output will be 1. Okay. So, later on I will write the outputs, I will show it to you. Okay. Next comes for your remembrance, you can write it down like this. For your remembrance, you can write it down one more column. Okay. I will just omit and I will show it to you for your remembrance. Okay. So, this will be q naught initial state, and here I am just dividing to one more column over here, and this is your output as 0, this is as output at 1. So, I am just writing out the current output, and later on I will write it down over here. So, q naught in the first step, q naught on seeing input alphabet 0, it is going to q 3 whose output is what, 0. Okay. Then q naught on seeing input alphabet 1, it is going to q 1 whose output alphabet is 1. So, which is the state which is having output alphabet is 1, q 1 1. So, I will write down as q 1 1 1. Okay. Next step, next state is what, q 1. Okay. Now comes the main important point is that q 1, if you look into q 1, q 1 is not single right now. Now, q 1 is divided into two states, one is q 1 0 and the other one is q 1 1. So, I have to write the same thing q 1 0 and q 1 1. I have to divide these q 1 into two states. Now, look into this particular concept, and both the transitions will, both the rows will be same. Okay. Whatever you are writing for q 1 0, it will be same for q 1 1. Okay. Now, let me check it out. Q 1 on seeing input alphabet 0, where it is going, q 0. Q 0 does not have any change. So, I will write down as q 0 output alphabet is what, 1. Q 0 output alphabet is 1. Now, q 1 on seeing input alphabet 1, where it is going, q 3. Is there any change in q 3? No change. So, that means what I will write, q 3 and output will be 0. So, the same step you need to write down in the next step. See, q naught 1, q 3 0, because this particular concept I am writing for whom, q 1 only, q 1 I have divided into q 1 0 and q 1 1. Okay. Now, comes to the next step, sorry, next step is what, q 2. So, if you look into q 2, q 2 will be what, q 2 0 and q 2 1. If you look into q 2 on seeing 0, where it is going, q 2, but whose output is what, 1. Therefore, which is the state which is having output as 1, okay, q 2 1, correct. Therefore, I have to write down what, q 2 1 1. Okay. Next, what, q 2 on seeing input alphabet 1, it is going to q 2, but whose state is what, 0. So, this state will be now q 2 0 and the output will be 0. Therefore, finally, the step, next step will also be the similar. So, q 2 1 1, q 2 0 0. I hope it is clear. Then finally, we are left out with q 3. So, q 3, what I can write it down, q 3, I can, q 3 on seeing input alphabet 0, where it is going, it is going to q 1, but output alphabet is what, 0. So, I will take which state, q 1 0. Okay. Next step is q 3 on seeing input alphabet 1, it is going to q 1 and q naught, but q naught out, there is no change. So, it will remain as it is. So, q naught output alphabet is 1. Therefore, finally, we got this transition table for the Mealy machine, and this is where we have divided q 2 and this is where I have divided q 1. So, finally, we got this table. Now, how to write down the final table? Just omit these output alphabets and simply write down q naught, q 1 0, q 1 1, q 2 0, q 2 1 and then q 3. So, here it will be q 3, q naught, q naught, q 2 1. Just simply write down the states, no need to just omit these outputs alphabet and then q 1 0. Okay. Here it will be q 1 1, q 3, q 3, q 2 0, q 2 0 and then q naught. Okay. Now, how to write down the output alphabets is as very simple, q naught. Now, look at the q naught, what is the output alphabet associated with q naught, 1, write it down here, q 1 0 0 1 0 1. How did I mention this? Because q 1 0 output alphabet is what, q 1 0 output alphabet is 0, okay, and q 1 1 output alphabet is 1. Similarly, q 2 0 output alphabet is 0, q 2 1 output alphabet is 1. Finally, q 3 output alphabet is what, 0. So, this is the final transition table of the Mealy machine. So, this is how you have to Murray machine. This is how you need to convert a Mealy to a Murray. So, first, most importantly, you just try to find out the states which are having more number of output alphabets, then try to divide it. Okay. So, this is how we have tried to convert all the important equivalence property of Murray to Mealy machine. So, thank you for watching this video.